So we'll start with the basics of a polygon. We should know that the angles in a triangle add up to 180. And for this first problem, we should know that the angles in a four-sided shape add up to 360. And the reason being is that you can fit two triangles into that four-sided shape, and 180 and 180 makes the 360. And that pattern carries on. So if it's got 5 sides, then we would add another 180 onto that, so we get 540. For 6 sides, we have another 180. You just keep on adding 180 each time for the number of sides that you've got. However, I think that's enough that I need for these for this first question, and equally the second question, as you'll see in a moment. So what you would do here is you would, calculator or otherwise, you'd add the 3 angles that you've been given in the diagram. So we've got 118 added to 78 added to 94 gives you 290. So the angle that's been marked as A would be 360 degrees. Take the 290. So 360, take that, which gives you 70 degrees. And it's worth putting the working down, because if you botch up with a bit of adding up, at least you get some credit for the working that you've done. So as I led on to, the next question is something similar, but just a little bit more advanced. It's got 5 sides, but I start with the same process. I add the 96, the 95, the 107 and the 113 together. So 96 added to 95 added to 107 added to 113 comes out to be 411. So the remaining angle B is not 360 this time, but 540. Take the 411. It's the same mathematics, but as I pointed out, for each polygon we increase the size of all the angles by 180, starting with the triangle being 180 degrees, then add 180 for the 4-sided, 360, for the 5-sided it'll be another 180, so 540. So 540, take that number, gives you 129 degrees. Now I could do this for the octagon. We've got 8 sides, so I could just keep on adding 180 degrees on each time from the triangle, and once I get to that grand total, just divide that by 8. However, there is a simpler way, if you learn the formulae, of establishing what the angle will be, the interior angle, this angle here, which is the same as each one of these. And it's done by working out, first of all, this angle, which we call the exterior angle. Now, to work out the exterior angle, I would take 360 degrees and I'd divide it by how many sides there are, which in this case is 8. So, calculator or otherwise, we divide the 360 by 8 and we get 45. So that angle there is 45. So therefore the interior angle will be 180 degrees. Take the angle we've just found, because angle's on a straight line, and that gives us 135 degrees. And that's the method I'm going to go with from here on, because my shapes now are regular polygons. And for a regular polygon, it simply implies that all of the sides are of the same length and all the interior angles are equal to one another. So this is the method that we would apply. So in this situation, we've not been given the diagram, just been given the fact that it is a regular polygon. We're told that it's got 12 sides. So, as I pointed out, I can work out the exterior angle first of all by doing 360 divided by how many sides? And that gives us 30. So, if I was just to draw a fraction of the polygon, what I've just established is that that angle there is 30 degrees. So the angle on the inside of the polygon would be 180 degrees. Take what I've just calculated, which is 150 degrees. Repeating what I did on the previous example. So how this can be used in different situations, as you can see I've drawn here a sketch of what's going on. We're told that the interior angle is 165, so we can see straight away that the exterior angle would have to be 15. Well, if I reverse the equation, if I work out 360 degrees divided by that 15, that will tell me how many sides it must have had. So 360 divided by 15 equals 24. So it must have had 24 sides. Because if I did 360 divided by 24, I'd come out with a 15. 180 take the 15, I'd come out with 165. I've just worked backwards. I'll repeat that with another situation. So here we are given that the interior angle was 140. Then that means that the exterior angle would have to be 40. So again, 360 degrees divided by 40 would give us an answer of 9, so it must have had 9 sides. And as I said, you can see 360 divided by the 9 would have got me the 40. 180 take the 40 would have got me the 140, which is where I started. Taking it even more challenging. So we've told that we've got two 5-sided polygons. Then if we look at 360 degrees divided by the 5, we get 72. So therefore the angle on the inside of each polygon would be 108 degrees. So that's 108 degrees, that's 108 degrees, all the way around that. And because this is an identical one, that's 108 degrees, that's 108 degrees, and so on. However, I'm just more interested in this part of the diagram. At that part of the diagram, we've got 108 degrees and another 108 degrees, which gives us 216 degrees. That tells me that x must be 360 degrees, take the 216. Why? Well, because all the way around in a circle is 360 degrees. If I already know two of the angles of them three, then subtracting those two angles must tell me the remaining angle. So we've got 360 degrees, take the 216 degrees, works out to be 144 degrees for value of x. One final one. So in keeping with the last example, I've got two regular polygons joined together, but I'm not interested in the interior angles. I'm interested in that exterior angle. That said, I have to work out the interior angles to work out that angle. The regular 3-sided polygon is the equilateral triangle, which you should know each angle is 60 degrees. 60, 60, 60 makes the 180. So that's an easy one to write in. As for this particular one, it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sides. So we've got 360 divided by 12 sides.